property states that for all numbers a, b, and c, if you are multiplying a times b plus c, that is equal to a times b plus a times c. So it's fair to multiply out the expression on the left to yield the expression on the right. So when we move forward like that, we're multiplying. Later in the course, you're going to hear about moving backwards, moving the opposite way, which is something called factoring. So you can multiply out or distribute an expression out differently, or you can go back the other way and factor. So focusing right now on multiplying or distributivity. This rule also holds true for subtraction. So if I say that I have a times b minus c equals ab minus ac, that is allowable. So the distributive property holds true for multiplying expressions that involve addition and subtraction. I can also reverse the order in which these are presented. I can first say b plus c times a, and the distributive property still holds up, and that would give me ba plus ca, which is equivalent to this top expression. I can just reverse the order of these variables if I would like. Again, it holds true for subtraction. So if I'm saying that I have the expression b minus c times a, that is equal to ba minus ca. This property also holds true for multiplying times several numbers that are being added or subtracted. And if I have 3 or more numbers, 2, 3, 4, however many numbers, I just take them in order, multiplying first a times b, and then plus a times d, so a times b, a times d, and then finally minus a times f. So the distributive property works even when there are several numbers or variables inside the parentheses. The first expression that we're going to evaluate involves only numbers. We don't have any variables to work with right now. And I'm going to handle this by first multiplying 7 times 8. Then I'm going to multiply the 7 times the second term, which is 5. So I'm going to do 7 times 8 plus 7 times 5. Okay, so 7 times 8 plus 7 times 5, and I'm going to follow my usual order of operations, and that tells me to multiply. First, 7 times 8 is 56 plus 35. And when I add those two together, it yields 91. Again, I use the distributive property to evaluate this expression by multiplying the 7 times 8 and then plus 7 times 5, multiplying those two out, 56 plus 35, and then adding those together to get my result. We're going to use the distributive property, but this time we have a variable. However, that doesn't change our approach. You handle it the same way that you handled the arithmetic expression that we just did. Again, I'm going to take the expression that I'm multiplying and multiply it first times the first term to give me 3x, and then times the second term. This can be further simplified. I have 3x, and then I'm going to further simplify that by multiplying out 3 times 5 equals 15. So the term I have up here, 3 times x plus 5, using the distributive property, can be changed into 3x plus 15. I have a more complex expression, and it's going to require us to remember how to multiply when there are powers involved. So what I'm going to do is multiply out my first term, and that's 5x times 3x squared, and then multiply out my second terms, 5x times 7x. Now, in order to completely multiply these out, I have to recall how I handle multiplying powers when I have the same base. So here I have x as the base, and if I'm multiplying x times x squared, I need to add the exponents. X can really be thought of as x to the first power. And if I'm multiplying these out, what I'm going to do is add the exponents. So it becomes x to the 1 plus 2, or x to the third. So recall that as you're doing this problem. Multiplying out 5 times 3 is 15. Using the rule I just discussed, x times x squared gives me x cubed. I'm going to do the same thing over here. And here I have 5 times 7, which is 35. Again, I'm dealing with multiplying out powers. X times x would give me x squared. And this gives me 15x cubed minus 35x squared. Looking back, using the distributive property, I multiplied out 5x times the first term, 3x squared, minus 5x times the second term, 7x. And simplifying that further, I got 15x cubed minus 35x squared. Finally, looking at this, I have an expression that actually has several terms that I'm going to apply the distributive property to. And recall at the beginning of this lesson, I mentioned that the distributive property does apply to more than 2 terms. So however many terms I have in here, I handle it the same way. I take the expression that I'm multiplying, the term that I'm multiplying, and just go systematically and multiply by each term inside the parentheses. Starting from the first term, that gives me minus 3y squared times 4y cubed minus 3y squared times negative 6y minus 3y squared times 7. Now, just carefully going through each of these, since it's a little bit more complex, I have negative 3 times 4. Simple enough, that's 12. Remember that if I'm multiplying y squared times y cubed, what I'm going to do is add the exponents. And that's going to give me y to the 5th. So I'm going to add the exponents. In the next section here, I have minus 3 times minus 6. A negative is going to give me a positive, so I'm going to have plus 18 y squared times y. That would be 2 plus 1, which is y cubed. And in my last section, I have negative 3 times 7 is negative 21, and then I don't have any y expression over here, so it's just y cubed. The final answer is negative 12 y to the 5th plus 18y cubed minus 21y squared. Again, what I did is I took negative 3y squared times 4y cubed, and that gave me negative 12y to the 5th plus 18y cubed minus 21y squared.